In example 92, we're going to sketch a graph of the log base 2 function. And I think the easiest way to try to end up with a graph of this log function is first to think about its inverse function. So the inverse function for this log base 2 is the exponential function of base 2. So I'll call that g of x. It's the function 2 to the x. These are inverses of each other. And when you have a graph of a particular function, you can obtain the graph of its inverse simply by reversing the roles of x and y on the coordinate plane. So let's start out as though we were sketching a graph of the inverse function 2 to the x. And you recall from when we did this in the beginning, in the last section, looking at exponential functions, we were able to do this by plotting some points. So I'm just going to plot out a few values of x and 2 to the x. I'll go from -2 to 3. And you might recall the values that we got. 2 to the -2 is a quarter. 2 to the -1 is a half. 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4, and 2 cubed is 8. And that got us these coordinate pairs that we use to help us plot the graph of 2 to the x. Of course, to get a sketch of, we're not graphing 2 to the x, we want to graph the log base 2 function. So these pairs right here that we just wrote down, these are on the 2 to the x graph. So let's get some xy pairs for values of the function log base 2 of x. And now we don't actually require any additional calculation. Since these are inverses, all I need to do is reverse the coordinates. So a quarter maps to -2. 1/2 maps to -1. 1 maps to 0. 2 maps to 1. 4 and 2. 8 and 3. So now these are the points that we're going to plot to end up with the graph of our function log base 2 of x. So now you'll notice we do get negative values for the outputs. We did not when we were working with the exponential functions, but you'll notice we cannot plug in any negative values for the inputs. And that is precisely because no input that we might plug into our exponential will produce a negative value. So now we can set about plotting our points. Here's about where 1/4 is on the x, and this maps to -2. 1/2 maps to -1. At x equals 1, we have a y value. Y coordinate is 0. At x equals 2, we've got a y coordinate of 1. At x equals 4, we have a y coordinate of 2. And we don't quite have enough space to go all the way out to x equals 8, but we could sort of see the pattern that establishes. And here's our graph of y equals log base 2 of x. It has a very similar shape to the exponential function, only this time we could observe that It's the y-axis that is an asymptote. There are no negative x-coordinates that will be on this graph. And it descends infinitely downward and does climb up as x increases, although somewhat gradually.